Tonight, we're not diving in a hurry. There's no countdown, no sudden drop. Instead, we're simply drifting toward the deepest places on Earth, far below the surface, beneath waves that have repeated the same motion for millions of years. There are places so deep, so quiet, that even sunlight has never reached them. These are the ocean trenches, vast cracks in the seafloor, where pressure replaces light and time seems to slow, almost to stillness. As you listen, there's nothing you need to imagine clearly, nothing you need to understand fully. Just allow your thoughts to move gently downward, one layer at a time. Tonight, we explore the ocean trenches and Earth's deepest secrets. The ocean has always been a place of comfort. The rhythmic sound of waves, the steady rise and fall of the tide, the sense that something ancient is breathing just beyond the shore. For most of human history, we believed the ocean was shallow, that its secrets rested just below the surface. But slowly, as ships traveled farther and instruments grew more precise, we discovered something unsettling. The ocean doesn't end where we can see it. In many places, the seafloor simply falls away. Not gradually, not gently, but suddenly, into depths deeper than any mountain is tall. These places are not caves, they are not holes. They are trenches, long, narrow valleys carved into the Earth's crust, stretching for hundreds, sometimes thousands of kilometers. Down there, pressure builds with every meter. Darkness becomes permanent, and the environment becomes one of the most extreme on the planet. And yet, life exists. Tonight's journey isn't about fear, or danger, or survival. It's about curiosity, about slowing down and allowing the ocean to reveal itself layer by layer, depth by depth. There's no rush to reach the bottom. In fact, we'll spend most of our time simply drifting, listening, and observing. Because the deeper we go, the quieter everything becomes. The calm surface. Before we descend into the trenches, we begin at the surface. This is the world we know best. Sunlight dances across moving water. Waves reflect the sky. And the boundary between air and sea feels familiar, almost safe. The surface ocean is alive with motion. Currents swirl. Winds push gently across open water. And temperature shifts create invisible highways for marine life. It's here where humans feel most comfortable. We swim, we sail, we fish, and we assume that what lies below is simply more of the same. But this assumption couldn't be further from the truth. The surface ocean represents only a thin skin, a fragile boundary between the world we experience and a realm we rarely visit. Below the sunlight zone, conditions change quickly. Light fades, temperature drops, pressure increases. Yet from the surface, none of this is visible. And that's part of what makes the ocean so deceptive. It looks calm, endless, and inviting. For centuries, this illusion shaped human understanding of the sea. Early sailors believed the ocean floor was flat, or gently sloping, like land hidden beneath water. They imagined vast underwater plains, not sudden drops, not massive chasms, not trenches deeper than the tallest mountains. It wasn't until the development of deep-sea sounding tools that this illusion began to break. As weighted lines were lowered, and later sonar pulses sent downward, something unexpected happened. In certain regions, the bottom never seemed to arrive. Measurements stretched longer and longer and longer. The ocean was far deeper than anyone had imagined, and beneath its calm surface, the earth itself was fractured. From above, the ocean appears smooth, almost peaceful. But this surface hides one of the most dramatic landscapes on the planet. A landscape shaped not by wind or rain, but by tectonic forces, slow, patient, and relentless. At the surface, we experience time in hours and days. In the trenches, time moves in millions of years. The calm surface is a gateway, a threshold between the familiar and the unknown. And as we remain here for a moment longer, floating, listening to the gentle rhythm of water, it becomes easier to understand why the ocean has always drawn us in. Not because it reveals everything, but because it keeps so much hidden. Soon, we'll begin our slow descent. But for now, we stay here, at the surface, where light still exists, and the ocean breathes quietly beneath us. When the ocean suddenly falls away from the surface, the ocean feels continuous. One stretch of water seems to blend effortlessly into the next, with no obvious signs of what lies beneath. But as we begin to descend, something subtle changes. The light no longer dances quite as freely. Colors soften, blues deepen, and the surface above slowly loses its sharpness. This is where the illusion of familiarity begins to fade. For a long time, humans believed the ocean floor mirrored the land above it. Rolling plains, gentle slopes, perhaps a few scattered hills. It was comforting to imagine the seafloor as predictable. But the truth is far more dramatic. As exploration advanced, scientists discovered that the seafloor doesn't always slope downward slowly. In many regions, it simply ends. One moment, there is ground beneath the water, and the next, there is nothing. This sudden drop marks the edge of the continental shelf, a vast underwater boundary where shallow seas give way to the deep ocean. From here, the descent becomes steep, not in a way you could see from above, but in a way that instruments, and later submersibles, would come to understand. Imagine standing at the edge of a cliff, one so wide you can't see its sides, and so deep the bottom is completely hidden. That is what the ocean floor does, again and again, across the planet. As we drift downward, pressure increases quietly. There's no sound, no warning, just a steady tightening of the environment around us. At the surface, your body experiences one atmosphere of pressure. But here, with every 10 meters of descent, another atmosphere is added. The ocean doesn't announce this change. It doesn't rush. It simply waits. This gradual buildup is part of what makes trenches so deceptive. They are not sudden holes punched into the earth. They are the result of movements so slow, so deliberate, that they unfold over millions of years. As tectonic plates drift, collide, and slide past one another. Some are forced downward, not shattered, not broken apart, but gently, persistently, pressed beneath neighboring plates. This process is called subduction, and it is the quiet architect of the deepest places on Earth. As one plate descends, the seafloor follows, and over time, a trench is formed. From above, this transformation is invisible. The ocean hides it completely. The surface remains calm. Waves continue their rhythm. Storms come and go. Meanwhile, far below, the Earth reshapes itself. As we descend past the continental slope, the environment grows calmer in an unexpected way. Waves no longer reach us. Surface noise fades. The water becomes heavier, still, and slow-moving. Here, the ocean feels less like water and more like a vast, quiet presence. Sound travels differently. Movement feels deliberate. This is the beginning of the deep ocean proper, a realm that covers more than half of Earth's surface, yet remains largely unexplored. And somewhere beyond this darkness, the trenches wait. They do not announce themselves with turbulence or motion. They are simply there, long, narrow, and impossibly deep. Early sonar readings puzzled scientists. Sound waves would be sent downward, expected to return after a predictable time, but in trench regions, the echoes came back late, or not at all. The ocean floor had dropped far deeper than expected. In some places, the depth doubled. In others, it tripled. These weren't shallow depressions. They were vast geological scars, stretching for hundreds of kilometers, and descending farther than Mount Everest rises above sea level. Yet despite their size, trenches occupy a strange place in human awareness. They are rarely visible on maps, rarely discussed, and almost never visited, not because they are hidden by distance, but because they are hidden by depth. Descending further, we enter a region where life becomes sparse, but not absent. Here, creatures drift rather than swim. Energy is conserved. Movement is minimal. Food is scarce, arriving slowly from above, in the form of sinking particles, organic debris, and the occasional large fall from the surface world. Time feels different here. Without sunlight, there is no day or night, only a continuous, unbroken stillness. This is the world just above the trenches, a waiting place. The final stretch before the ocean floor falls away completely. And as we approach that edge, there is no dramatic moment, no sudden sensation, just a quiet realization that beneath us, the earth opens into its deepest secrets, and slowly, almost imperceptibly, we drift closer to the point where the ocean no longer slopes, but plunges. What is an ocean trench? As we hover near the edge, where the seafloor no longer slopes gently, it's natural to pause, not out of fear, but out of quiet curiosity. What exactly is an ocean trench? The word itself sounds dramatic, almost violent. A trench suggests something torn open, a sudden wound in the earth, but the reality is far calmer, far slower, and far older. An ocean trench is not a hole. It is not a crack formed by a single event, nor a collapse caused by weakness. Instead, it is a long, narrow valley, pressed into the seafloor over immense spans of time. To understand trenches, we have to let go of the idea that Earth is static. The planet beneath us is always moving, even when everything feels still. The ground beneath the ocean, and beneath our feet on land, is broken into massive sections called tectonic plates. These plates are not small. They are enormous, some larger than continents, floating slowly on a layer of softer rock beneath them. Their movement is almost impossible to notice. They drift at roughly the speed your fingernails grow. And yet, given enough time, this gentle motion reshapes the entire planet. Where plates meet, the Earth changes. Sometimes they pull apart, allowing magma to rise and form new crust. Sometimes they slide past one another, releasing energy as earthquakes. And sometimes, one plate is forced beneath another. This is where ocean trenches are born. In these regions, the denser plate, usually an oceanic one, begins a slow descent into the mantle. Not all at once, not suddenly, but millimeter by millimeter, year after year, century after century. As the plate bends downward, the sea floor above it follows, and over millions of years, a trench forms, long, narrow, and astonishingly deep. From above, this descent is invisible. The ocean smooths everything over. Waves continue their rhythm. Storms pass. Clouds reflect on the surface. The planet appears unchanged. But far below, the Earth is folding in on itself. Most trenches form near the edges of continents, or along chains of volcanic islands. They often run parallel to coastlines, hidden just offshore, and despite their size, they occupy a surprisingly small fraction of the ocean floor. Yet they account for the deepest places we know. The deepest point on Earth, the Challenger Deep, lies within the Mariana Trench, nearly 11 kilometers beneath the surface. To put that into perspective, if Mount Everest were placed there, its peak would still be submerged by more than a mile of water. And yet, this incredible depth is not abrupt. The descent is gradual, almost gentle. When experienced over distance, trenches stretch horizontally for hundreds or thousands of kilometers. While descending slowly into darkness, they are less like pits and more like immense valleys, pressed quietly into the seafloor. As we continue drifting downward, pressure builds steadily. The water grows heavier. Movement becomes more deliberate. Sound softens. Here, physics begins to behave differently. Materials that feel solid at the surface would crumple under the weight. Air-filled spaces collapse instantly. Only specially designed vessels with thick, spherical hulls can survive the descent. And yet, life remains. This is one of the most remarkable truths about trenches. Despite crushing pressure, despite freezing temperatures, despite complete darkness, living organisms endure, not by resisting the environment, but by becoming part of it. Their bodies contain no empty spaces. Their cells are adapted to pressure. Their movements are slow, efficient, intentional. In trenches, nothing is wasted. Energy is precious. Food arrives rarely, often drifting down from above, sometimes taking weeks or months to reach the bottom. Because of this, life here exists in a constant state of patience. Nothing rushes. Nothing needs to. The trench environment rewards stillness, and this stillness is part of what makes trenches feel so different from the rest of the ocean. There are no currents here like those near the surface, no crashing waves, no sudden changes, just a steady, unbroken quiet. As scientists began to map the ocean floor more precisely, trenches revealed themselves as some of the most consistent features on the planet. They mark the boundaries between tectonic plates. They trace the edges of continents. They form a kind of hidden framework, guiding earthquakes, volcanoes, and even the slow recycling of Earth's crust. Over time, as one plate descends, it carries sediments, organic material, and even traces of life deep into the mantle. In this way, trenches are not just endpoints. They are pathways, connections between the surface world and the deep interior of the planet. They are places where Earth breathes inward, drawing material down before eventually returning it through volcanic activity elsewhere. And yet, for all their importance, trenches remain largely unexplored. We know more about the surface of Mars than we do about the deepest parts of our own oceans. Not because the trenches are far away, but because they are difficult to reach, expensive to study, and psychologically challenging to enter. Descending into a trench means accepting isolation. There is no light, no easy escape, no margin for error. Even today, only a handful of humans have ever reached the deepest trench floors, and each descent has been slow, careful, and brief. The trenches prefer to remain undisturbed. They do not resist exploration, but they do not invite it either. They exist on their own timescale, unaffected by surface events. Wars come and go, civilizations rise and fall, and the trenches remain unchanged. As we continue our descent, the walls around us stretch upward, vanishing into darkness. The bottom is still far below. But now, we understand what we're moving toward. Not a hole, not a void, but a quiet, ancient feature of the planet. A place shaped by patience, by pressure, and by time itself. And somewhere deeper still, specific trenches await, each with its own shape, its own history, and its own secrets. The first time humans found the abyss. For most of human history, the deep ocean existed only as an idea. People stood at the shore, looked out across the water, and imagined that the depths below were knowable, even if unseen. Early civilizations believed the sea had limits, that somewhere beneath the waves, there was solid ground, not too far down, not too different from the land above. Some imagined underwater plains. Others believed the ocean rested on pillars, or that it simply faded into darkness and mystery. These ideas were not born from ignorance, but from necessity. Humans explored the world using sight and breath and muscle, and the ocean quickly took all three away. Before modern technology, there was no way to see beneath the surface, no way to measure depth accurately, and no way to survive long enough to explore it. So for centuries, the abyss remained untouched and mostly unquestioned. Sailors crossed vast oceans, navigators charted coastlines, and maps slowly filled in with detail. But beneath those lines and labels, the seafloor remained blank. In the early days of exploration, depth was measured using a simple method: a rope, a weight, and patience. The rope would be lowered over the side of a ship, hand over hand, until it stopped descending. When the weight touched bottom, the length of rope was measured, and the depth recorded. This worked well enough in shallow coastal waters, but in the open ocean, something strange happened. The rope kept going, and going, and going. Sometimes, it never reached the bottom at all. Sailors assumed the rope had drifted sideways, or that currents were interfering. Others believed the rope had broken, or tangled. The idea that the ocean could be endlessly deep was unsettling, so it was often dismissed. But as exploration continued, and measurements became more frequent, a pattern began to emerge. In certain regions, depth readings were consistently longer, not just a little deeper, but dramatically so. These weren't random anomalies. They were hints, clues that the seafloor was not uniform, that somewhere beneath the calm surface, the earth dropped away more sharply than anyone had imagined. The true shift came in the 19th century, when scientific curiosity began to replace myth. Expeditions were launched, not just to travel, but to understand. One of the most important was the voyage of HMS Challenger. Between 1872 and 1876, the Challenger crossed the world's oceans, lowering weighted lines, collecting samples, and recording depths with unprecedented care. What they found changed everything. In the Western Pacific, the sounding line descended farther than ever before, deeper than expected, deeper than believed possible. The rope measured more than 8 kilometers, and still, the bottom seemed distant. This region would later be known as the Challenger Deep. At the time, there was no celebration, only quiet disbelief. The discovery didn't feel triumphant. It felt disorienting. The realization that Earth contained places this deep, this unreachable, forced scientists to rethink their understanding of the planet. The ocean was not a shallow skin. It was a vast volume, holding landscapes more extreme than those on land. Mountains, valleys, and trenches, hidden beneath kilometers of water. As the years passed, new tools emerged. Echo sounding replaced ropes. Instead of lowering a line, ships sent sound waves downward and measured how long they took to return. This method revealed the seafloor in broad strokes, like shadows forming in darkness. And those shadows showed something remarkable. Trenches were not isolated. They formed long chains, curving along the edges of continents, tracing invisible boundaries beneath the ocean. The Earth's surface, both above and below water, was connected, but even with better maps, the trenches themselves remained untouched. Knowing a place exists is not the same as visiting it. For decades, the depths were measured, calculated, and discussed, but never seen. It wasn't until the mid-20th century that humans attempted something unprecedented: to descend, in person, into the abyss. The vessels built for this task were unlike ships or submarines. They were small, heavy, and designed for pressure, not speed. Their walls were thick, their interiors cramped, and their windows tiny. Inside, there was silence, broken only by the creaking of metal as pressure increased. The first crewed descent to the deepest trench was made in 1960 by the bathyscaphe Trieste. Jacques Picard and Don Walsh descended into the Mariana Trench, reaching the Challenger Deep after nearly 5 hours. Outside, pressure exceeded 1,000 atmospheres. Inside, the world was still. They reported a flat seafloor, fine sediment, and surprising signs of life. Not monsters, not chaos, just quiet and persistence. This moment confirms something profound. The deepest places on Earth were not empty. They were alive, in ways subtle and slow. And yet, after this historic dive, decades passed before another human returned. Not because it was impossible, but because the trenches demand patience, resources, and a willingness to enter places where nothing is familiar. Even today, descents into trenches are rare. Each one feels less like exploration and more like a visit, a brief moment of presence in a realm that does not belong to us. As we drift deeper now, carrying the memory of those first discoveries, we begin to sense why the abyss remained hidden for so long. Not because it was secretive, but because it exists beyond urgency. The trenches wait. They always have, and they are content to be discovered slowly. Pressure, the invisible force. As we descend further, there is still no sound, no warning, no sudden sensation. And yet, everything is changing. Pressure is not something we can see. It doesn't announce itself with movement, or color, or light. It simply exists, quietly increasing. With every meter of depth, at the surface of the ocean, pressure feels normal. It's the pressure we live with every day. The weight of the atmosphere pressing gently against our bodies. We rarely notice it. Our bodies are adapted to it, balanced with the air inside our lungs, our blood, our cells. But as we move downward, the balance begins to shift. Water is heavy, much heavier than air. And unlike air, it does not compress easily. Every column of water above us adds its weight. 10 meters down, the pressure has doubled. 100 meters, 10 times greater. 1,000 meters, 100 times. By the time we reach trench depths, the pressure is more than 1,000 times what we experience at the surface. And still, there is no sensation, no feeling of being crushed. Because pressure works evenly. It presses from all directions at once. There is no single force pushing inward, no direction to resist, only an invisible presence, filling every space, testing every structure, quietly asking whether it belongs here. For human-made objects, the answer is usually no. Unprotected metal buckles, glass shatters, air-filled spaces collapse instantly. Even submarines, carefully engineered for depth, have limits. Beyond those limits, the ocean does not negotiate. It simply closes in. This is why vessels designed for trench exploration look unusual. They are not streamlined or elegant. They are dense, compact, and often spherical. A sphere distributes pressure evenly, giving it no weak point. Inside, the space is small. Movement is limited. Comfort is secondary. Survival comes first. And yet, outside those thick walls, life continues. This is one of the quiet miracles of the deep ocean. Creatures that live in trenches do not resist pressure. They embrace it. Their bodies contain no empty air spaces. Their tissues are soft, flexible, and resilient. Pressure does not crush them, because there is nothing inside to collapse. Even their chemistry is adapted. Proteins that would unravel at surface pressure remain stable here. Cell membranes stay intact. Life adjusts, not by fighting the environment, but by becoming part of it. Movement in the trench is slow, not because creatures are weak, but because energy is precious. Food is rare. Every motion must be efficient. Every decision, deliberate. Some animals drift rather than swim. Others rest on the sea floor, waiting for particles to fall, for organic material to settle, for the ocean above to deliver what it can. Pressure shapes behavior as much as it shapes bodies. In this world, there is no sudden escape, no quick retreat. Everything happens gradually, even death. As we descend further, the water grows colder. Temperatures hover just above freezing, but remain remarkably stable. Here, the ocean feels less like a fluid and more like a dense, still presence. Sound travels differently under pressure. Low-frequency noises move vast distances, while higher frequencies fade quickly. The ocean becomes a place of deep listening, where even distant events leave subtle traces. Earthquakes, ice breaking far away, storms on the surface, all send whispers through the deep. Pressure also changes time. at least in the way it feels. Without sunlight, there is no day or night, no rhythm to mark passing hours. Life follows slower cycles. Growth is measured in years, sometimes decades. Change is subtle. Nothing is rushed. This is why the trenches feel ancient, not because they are old, though they are, but because they move at a pace that ignores human urgency. Pressure enforces patience. It demands stillness. And as we continue drifting downward, surrounded by this invisible force, it becomes easier to understand why the deepest parts of the ocean remain so undisturbed. They are not hostile. They are simply unyielding. Only those willing to slow down, to adapt, to exist without resistance, can remain here. And somewhere below us, in even deeper darkness, life has done exactly that, waiting, darkness that never ends. As we drift deeper, the last traces of sunlight begin to fade. At first, the change is subtle. Colors soften, edges blur. The bright blues of the surface darken into deeper shades, until eventually, blue gives way to black. This is not the darkness of night. Night still carries light, reflected moonbeams, distant stars, a sense that morning will return. This darkness is different. It is complete. Beyond a certain depth, sunlight can no longer reach us. No matter how calm the surface may be, no matter how clear the water, light simply runs out. It is absorbed, layer by layer, until nothing remains. This boundary is known as the midnight zone, but the name is misleading. Midnight implies a passing moment. Here, midnight never ends. There is no dawn waiting beyond the horizon, only a continuous, unbroken absence of light. In this environment, vision loses its meaning. Eyes, as we understand them, are no longer useful. Some creatures retain them, sensitive enough to detect faint glimmers of bioluminescence. Others abandon sight entirely. In the trenches, seeing is optional. Feeling, sensing, and waiting become far more important. Darkness reshapes behavior. Movement becomes cautious. Energy is conserved. There is no reason to rush. Because there is nowhere to run, predators do not chase for long distances. Prey does not flee blindly. Instead, encounters happen slowly, often without warning. A gentle brush of water, a subtle vibration. The deep ocean communicates through touch, through pressure waves, through faint chemical traces. In this darkness, sound becomes a guide. Low frequencies travel far. The distant movement of water, the slow shifting of the seafloor, even the quiet grinding of tectonic plates can be felt. The trenches are never truly silent. They are simply very quiet. Bioluminescence becomes one of the few sources of light. Soft glows, gentle flashes, brief signals in the dark, not for beauty, but for survival. Some organisms use light to attract food. Others use it to communicate. A few use it to confuse predators, releasing clouds of glowing particles, then drifting away unnoticed. But even bioluminescence is rare in the deepest trenches. Energy is too valuable to waste on display. Most life here prefers invisibility. Darkness also affects time. Without light, there are no shadows to mark movement, no sunrise, no sunset, only a continuous present. For organisms living here, biological clocks slow. Growth takes years. Reproduction happens infrequently. Life stretches itself thin. carefully, across long spans of time. As we continue our descent, the darkness feels less oppressive and more comforting. It removes distraction. There is nothing to look at, nothing demanding attention, only the sensation of being held, suspended, in a vast, quiet space. This is why many who descend into the deep describe it as calming, not because it is safe, but because it is honest. There is no illusion here, no surface shimmer, no hidden movement, just depth, darkness, and patience. In the trenches, darkness is not the absence of life. It is the condition that shapes it. And far below, where pressure peaks and darkness is absolute, life continues, almost unnoticed, waiting as it always has. Strange life in the trenches. In the deepest parts of the ocean, life does not announce itself. There are no sudden movements, no bright colors flashing through the water, no signs meant to draw attention. Here, existence is subtle. The creatures that live in the trenches are not strange because they are frightening, but because they are perfectly adapted to a world so different from our own. They move slowly, deliberately, as if conserving every moment. Many have soft, fragile-looking bodies, not built for strength, but for endurance. In an environment where pressure would crush most forms of life, rigidity is a disadvantage. Flexibility becomes survival. Some trench-dwelling organisms resemble those found in shallower depths, but with important differences. Their muscles are less dense. Their skeletons, if present at all, are lighter or reduced. Empty spaces inside the body are avoided. There is no room for air. Every part is filled, balanced, in harmony with the surrounding pressure. One of the most common life forms in the trenches is also one of the smallest. Amphipods, shrimp-like creatures, translucent, quiet, and remarkably resilient. They drift, crawl, and wait. When food arrives, often in the form of sinking organic matter, they gather slowly. Nothing is wasted. Every particle is valuable. Larger animals are rare, but not absent. Some fish live here, their bodies elongated, their movements minimal. Their eyes, if they have them, are often reduced or adapted to detect faint light. Others rely on scent or subtle vibrations in the water. In the trenches, food webs are simple, but efficient. There is little competition. The environment itself limits population. Only those perfectly suited to the conditions can persist. Reproduction happens slowly. Some species produce very few offspring, but invest heavily in their survival. Others release larvae that drift upward, toward shallower waters, before slowly returning downward as they mature. Life here is connected to the surface, but only indirectly. Most energy originates above, falling slowly through the water column. But in some trench regions, another source of energy exists: chemical energy. In places where tectonic activity allows fluids to seep from the earth, microorganisms thrive. They do not rely on sunlight. They use chemical reactions to produce energy, a process known as chemosynthesis. These microbes form the base of unique ecosystems, quietly supporting life in complete darkness. The presence of these organisms has changed how we think about life, not just on Earth, but beyond it. If life can exist here, under crushing pressure, without light, feeding on chemistry rather than sunlight, then similar life could exist elsewhere. In the subsurface oceans of distant moons, beneath icy crusts. In places once thought impossible, the trenches remind us that life does not require comfort, only stability. As we drift among these quiet inhabitants, it becomes clear that nothing here is rushed. There is no urgency. The deep ocean rewards patience and punishes waste. Creatures that survive here do so by blending in, by waiting, by doing as little as necessary. Even death is quiet. When an organism dies, its body sinks slowly, becoming nourishment for others. Nothing is lost. The trenches recycle everything. This constant reuse, this slow exchange of matter, has been happening for millions of years, long before humans existed, long before the surface world took its current shape, and it will continue long after. As we continue drifting downward, life becomes even more sparse. The water grows stiller. The space between organisms widens. But even here, in near emptiness, life persists. Not loudly, not proudly, but patiently. Sounds from the deep. In the deepest parts of the ocean, sound becomes more important than sight. Without light, without clear visual markers, the ocean communicates in other ways. Every movement, no matter how small, creates a ripple, a shift in water, a distant vibration, a low, traveling hum. Sound travels differently in the deep. Water carries it farther than air, especially at low frequencies. A single noise, made hundreds of kilometers away, can arrive here, softened, stretched, but still recognizable. In the trenches, the ocean is never truly silent. It listens, and it remembers. The earth itself speaks here. Tectonic plates grind slowly, creating vibrations that pass through water and stone. Subtle tremors, far too small to be felt on land, move through the deep like distant breaths. Even the slow settling of sediment creates faint sounds, tiny grains landing on the seafloor. One by one, life contributes its own quiet signals. Some creatures produce low-frequency sounds, not to communicate over long distances, but to sense their surroundings. Others respond to vibrations, detecting movement through touch rather than hearing. In the absence of light, sound becomes a form of awareness. Human technology has allowed us to listen in. Hydrophones, placed deep in the ocean, have captured sounds unlike anything heard at the surface. Long, drawn-out tones, slow pulses, deep echoes that seem to come from everywhere and nowhere. Some sounds are easily explained. Ice breaking far away, submarine landslides, underwater earthquakes. Others remain uncertain, not mysterious in a frightening way, but in a quiet, unresolved way. The ocean does not rush to explain itself. It simply continues. Sound also travels through layers of water differently. Changes in temperature and pressure create channels where sound can move efficiently, sometimes circling entire ocean basins. A whale's call, released near the surface, can be heard thousands of kilometers away, its tone bending and reshaping as it travels. In the trenches, these distant sounds arrive faint, but present, reminders that the surface world still exists, far above. Yet the deeper we go, the fewer of these sounds reach us. The trench walls absorb noise. The water grows denser. Eventually, even the echoes fade. What remains is a kind of background presence, not silence, but steadiness. A constant low-level hum, the sound of a planet in motion. For those who have descended into the deep, this soundscape can feel calming. It lacks sharpness. There are no sudden noises. Everything arrives slowly, softened by distance, smoothed by pressure. The ocean filters urgency out of sound. In this environment, even time feels quieter. Moments stretch. Events feel distant. The mind begins to drift, matching the pace of the water. As we continue our descent, the sounds grow fewer and farther apart. Eventually, only the quiet presence of the ocean remains, listening, waiting, breathing in its own way. The Mariana Trench. As we drift farther downward, one trench begins to stand apart from all the others. Not because it is louder or more dramatic, but because it is deeper, much deeper. This is the Mariana Trench, hidden beneath the western Pacific Ocean, stretching quietly for nearly 2,500 kilometers. It holds the deepest point on Earth ever measured. From the surface, there is nothing to see. The water looks like any other part of the ocean. Ships pass overhead, clouds drift by, storms come and go, and beneath it all, the Earth falls away. The Mariana Trench formed where two massive tectonic plates meet, the Pacific Plate and the Mariana Plate. Here, the Pacific Plate bends, slowly, patiently, and slides beneath the smaller plate beside it. This motion is almost impossible to notice. It happens at a rate of only a few centimeters per year. But over millions of years, it has created a valley deeper than any mountain is tall. At the deepest part of this trench lies a place known as the Challenger Deep, nearly 11 kilometers beneath the surface. To reach it, we must descend longer than it takes to climb Everest, twice over. As we begin this descent, everything slows. Pressure increases steadily. The water grows colder, denser, heavier. Sunlight vanished long ago. Bioluminescence becomes rare. The trench walls rise beside us, steep, dark, and disappearing upward into blackness. This descent is not dramatic. There are no sharp drops, just a long, continuous glide downward, hour after hour, meter after meter. This is why reaching the bottom of the Mariana Trench takes so long. Not because the journey is difficult, but because the depth is patient. At around 6 kilometers down, pressure exceeds 600 times that at the surface. At 10 kilometers, it is more than 1,000 times greater. Outside, water presses with unimaginable force. Inside any vessel, silence. Only the faint creak of metal, adjusting, responding, holding. The first humans to make this journey did not describe fear. They described stillness, a sense that the world had narrowed to a single point, surrounded by darkness. When the bottom finally appeared, it was not what many expected. No jagged rocks, no dramatic formations, just a flat, soft seafloor, covered in fine sediment. A quiet place. Life existed there, not in abundance, but unmistakably present. Small organisms moved slowly, evidence that even here, at the most extreme depth on the planet, the ocean supports life. Since that first descent, only a handful of missions have returned. Not because the Mariana Trench resists exploration, but because it does not invite repetition. Every descent is expensive. Every journey requires preparation, precision, and patience. The trench remains, mostly untouched. And perhaps that is fitting. The deepest place on Earth does not demand attention. It does not announce itself, it simply exists. As we linger here, hovering above the seafloor, it becomes clear why the Mariana Trench holds such a powerful place in human imagination. It represents a boundary, not just of depth, but of experience. Beyond this point, there is nowhere deeper to go, only inward, into reflection, into quiet, into the understanding that even on our own planet, there are places that remain almost entirely unknown. And as we begin to drift upwards slightly, leaving the Challenger deep behind, the trench closes around us once more, silent, patient, unchanged. What lives at the bottom? At the very bottom of the trenches, life does not gather in crowds. It appears slowly, quietly, often when least expected. Here, conditions are more extreme than anywhere else in the ocean. Pressure is immense. Temperature is near freezing. Darkness is complete. And yet, life endures. The organisms that live at these depths are not built for speed or strength. They are built for persistence. One of the most common forms of life at the trench floor is microbial, microscopic organisms embedded in sediment, slowly processing the materials that drift down from above. These microbes form the foundation of the deepest ecosystems on Earth. They break down organic matter, releasing nutrients, sustaining the few larger organisms that can survive here. Above them, on the soft sediment, small invertebrates move carefully. Sea cucumbers, flat, translucent, drifting just above the seafloor, feeding on particles that settle below. They move slowly, almost drifting rather than crawling. Amphipods are also common here. Shrimp-like creatures, small, quiet, and remarkably adaptable. They gather when food arrives, often surrounding a rare carcass or organic fall, a dead fish from above, a drifting jelly. Even plant matter becomes a temporary oasis. Life concentrates briefly, then disperses once again. Larger animals are rare, but they exist. Some fish species live at these depths, their bodies pale, their movements deliberate. Their bones are less dense, their muscles softer, their metabolism slow. They do not chase prey, they wait. In the trenches, waiting is a survival strategy. Energy is too valuable to waste. Even predators conserve motion. Encounters are brief. A single successful feeding may need to last weeks or months. Reproduction is equally restrained. Some trench species reproduce only occasionally, producing very few offspring. But those offspring are well adapted. They grow slowly, sometimes taking decades to mature. Time stretches here. Life unfolds on a different scale, one that is difficult to measure from the surface. Despite the isolation, the trench floor is not disconnected from the rest of the ocean. Material from above, sometimes called marine snow, drifts downward continuously. Tiny particles, dead plankton, organic debris, slowly sinking. It can take weeks or even months to reach the bottom. By the time it arrives, it is sparse but precious. Every particle matters. Occasionally, larger falls occur. A whale dies at the surface, and its body sinks. When this happens, it creates a temporary ecosystem. Scavengers arrive slowly. Microbes multiply. Chemical reactions release energy, supporting life for years, sometimes decades. Even in the deepest trenches, these events leave traces, evidence that the surface world still influences the abyss. As we drift just above the trench floor, it becomes clear that life here is not fragile. It is resilient, not because it is strong, but because it is patient. The organisms of the trench do not resist their environment. They belong to it. And in doing so, they remind us of something fundamental. Life does not need comfort. It needs balance. And somewhere beneath us, in the soft sediment, that balance continues, quietly, unnoticed. Human descents into the trenches. For most of human history, the trenches existed without witnesses. They were measured, mapped, and imagined, but never seen. Descending into the deepest parts of the ocean is not an act of conquest. It is an act of trust. Trust in engineering, in preparation, and in patience. The first human descents into trenches were not made in sleek vessels. They were made in small, heavy, slow-moving crafts, built for survival rather than comfort. Inside, space was limited. Movement was restricted. There were no panoramic windows, only small viewports, thick glass, and darkness beyond. The journey downward took hours, not because of technical limitations, but because the ocean does not allow speed. Rapid descent creates risk. Pressure changes must be gradual. Every meter requires adjustment. Every sound is monitored. As the vessel sinks, communication with the surface fades. Radio waves do not travel well through water. Instead, thin cables or acoustic signals become the only connection, and eventually, even those fall silent. At depth, the crew is alone, surrounded by kilometers of water, held in place by a shell of metal, no thicker than necessary. The experience is often described as strangely calming. There is nothing to do but wait. No distractions, no sudden movements, just the steady descent and the faint sounds of the vessel responding to pressure. When the bottom finally appears, it does so slowly. A faint reflection, a change in texture, sediment drifting upward. As the vessel settles nearby, the sea floor does not greet visitors. It simply exists. During these brief visits, samples are collected, images are recorded, instruments are deployed, but time is limited. The ocean does not forgive mistakes. Every descent carries risk. And so, humans do not linger. After a short time, the ascent begins, slowly, carefully, returning to a world of light, sound, and motion. Between descents, years, sometimes decades, pass. Each visit adds a small piece of understanding, but the trenches remain, largely unchanged. In recent years, technology has improved. Uncrewed vehicles descend more frequently. Robotic explorers collect data, capture images, and map the sea floor with increasing detail. But even these machines move slowly. They do not rush. The trenches demand respect, even from technology. Human descents into trenches are rare, not because they are impossible, but because they are unnecessary. The trenches do not need to be conquered or claimed. They do not contain resources easily extracted or territories to be defended. They exist beyond urgency, and perhaps that is why each descent feels meaningful. A reminder that exploration does not always require ownership. Sometimes it is enough to observe, to listen, and to leave quietly. As we drift away from the presence of human machines, the ocean returns to its steady rhythm. The trench resumes its silence, unbothered, unchanged, waiting, lost objects in the abyss. Far above the trenches, human activity continues. Ships cross oceans. Cargo moves between continents. Exploration leaves traces. And occasionally, something falls. Not deliberately, not ceremonially, just quietly, slipping from the surface world into the deep. The trenches have become unintended archives, places where objects drift downward, slowly, sometimes for weeks, before settling into darkness. Unlike the surface, the deep ocean does not erase quickly. There is no sunlight to fade colors, no strong currents to scatter debris. Things remain, often exactly where they land. Fragments of equipment, pieces of metal, tools lost during exploration, even traces of human presence, descend eventually to the deepest places. When researchers first explored trench floors, they were surprised by what they found. Not cities, not structures, but subtle reminders that the surface world extends farther than expected. Plastic fibers embedded in sediment, synthetic materials caught in soft mud, objects carried by currents, then released into stillness. These discoveries were not dramatic. They were unsettling, in a quiet way, because they revealed something important. The trenches are not isolated. They are connected by gravity, by water, and by time. Everything that enters the ocean eventually moves downward. Some objects break apart slowly, others persist. In the absence of light and biological activity, certain materials remain unchanged for decades or longer. The deep ocean preserves. It does not judge. It simply holds. Even natural objects become part of this record. Bones sink. Shells settle. Volcanic ash drifts down, layer by layer, marking moments in geological time. In this way, the trench floor becomes a timeline. Each layer of sediment tells a story. Of storms on the surface, of eruptions far away, of climate shifts over centuries. Human objects become just another layer, a brief moment in a much longer history. The ocean does not prioritize. It treats all material equally. What falls, stays. For life in the trenches, these objects are neither useful nor threatening. They simply exist, a foreign texture in an otherwise uniform world. Over time, microorganisms may colonize them. Slow chemical reactions may begin, but nothing happens quickly. The abyss is patient. As we drift above the seafloor, passing over scattered fragments, it becomes clear that the trenches serve as reminders, not of achievement, but of reach. That even in places we rarely visit, our influence can arrive, quietly, unintentionally. And once it does, it remains. The trenches do not return what they receive, they keep it. And in doing so, they offer a rare perspective, one that stretches beyond decades, beyond generations, into deep time. As we continue our journey, the traces of humanity fade again, replaced by sediment, darkness, and stillness. The abyss resumes its role as a silent keeper, holding stories without telling them. Time moves differently down here. Down here, time does not announce itself. There are no clocks, no schedules, no clear beginnings or endings. Without sunlight, there is no day, no night, no familiar rhythm to follow. Time becomes something else. At the surface, time is measured in seconds, minutes, hours. It moves quickly, often faster than we expect. But in the trenches, time stretches. Moments blend together. Change becomes subtle, almost unnoticeable. A grain of sediment settles on the sea floor and remains there, undisturbed. For centuries, a small organism grows, not over weeks or months, but over years, sometimes decades. Life adapts to this pace. There is no advantage in haste. Food arrives slowly, unpredictably. Energy must be conserved. Waiting becomes a skill. Even geological processes slow, at least from a human perspective. Tectonic plates continue their movement, but so gradually that a single lifetime is not enough to notice the change. In the trenches, mountains do not rise, and valleys do not deepen. Within a generation, everything unfolds on scales too large to be felt. This sense of deep time can be difficult to imagine. Our minds are shaped by urgency, by deadlines, by short-term outcomes. But here, urgency dissolves. Nothing needs to happen soon. Nothing is late. Nothing is early. There is only progression, slow, patient, inevitable. Sediment accumulates layer by layer. Each layer records a moment, not in days, but in years. Volcanic ash settles from distant eruptions. Microscopic shells drift down, after the organisms that created them have long disappeared. Together, these layers form a quiet archive, a history written without words. In this environment, even extinction feels different. Species do not vanish suddenly. Populations decline slowly, sometimes over thousands of years. Life fades, rather than ending abruptly, and new life appears, just as gently. The trenches remind us that time is not always something we move through. Sometimes, it is something we rest within. As we drift here, suspended in darkness, it becomes easier to let go of the surface world's pace. The mind slows. Thoughts stretch out, with no need to reach conclusions. This is why the deep ocean feels calming to many. Not because it is empty, but because it is unhurried. It does not demand attention. It does not ask for reaction. It simply continues. And in that continuation, there is comfort. As we prepare to move onward, leaving this sense of deep time behind, the trenches remain unchanged, patient, quiet, unconcerned with how long we stay or how quickly we leave. Are trenches older than we think? When we think about age, we often think in human terms: years, centuries, millennia. But the trenches do not belong to human time. They are shaped by processes so slow that even the oldest civilizations appeared only moments ago. By comparison, the earth beneath the ocean is constantly moving. Not dramatically, not suddenly, but persistently. Tectonic plates drift, collide, and sink. And as they do, trenches form, deepen, and sometimes disappear. This raises a quiet question. Are the trenches we know today the first of their kind? Or are they part of a much longer cycle? Evidence suggests the latter. The ocean floor is young, at least compared to continents. Most of it is less than 200 million years old. Older crust has been recycled, drawn down into the mantle through subduction zones, many of which once held trenches of their own. This means that trenches have existed and vanished many times over Earth's history. Each generation of trenches forms serves its role. and is eventually consumed. What we see today are only the latest expressions of a process that has been repeating for billions of years. Ancient oceans once covered areas now far inland. Their trenches, long gone, left only subtle clues in rock layers, folded mountains, and mineral deposits. By studying these remnants, scientists can trace the outlines of vanished seas and the deep valleys that once marked their edges. The trenches we observe today are temporary features in a planet that never truly rests. But temporary, in geological terms, still means enduring beyond comprehension. A trench may exist for tens of millions of years, long enough for species to evolve within it, long enough for sediments to build vast archives, long enough to shape the climate and the chemistry of the oceans above. As we drift along the trench floor, it becomes clear that age here is layered. The sediment beneath us records ancient storms, distant volcanic eruptions, shifts in ocean circulation. Each layer tells a quiet story, one that requires patience to read. And beneath that sediment, the crust itself carries memory of bending, of pressure, of descent. The earth remembers where it has folded, even after the surface changes. In this way, trenches are not isolated features. They are part of a larger rhythm, a cycle of creation, destruction, and renewal. As old crust sinks, new crust forms elsewhere. As trenches deepen, mountains rise. The planet balances itself, slowly, without urgency. This perspective can be grounding. It reminds us that the world does not revolve around human timelines. That change does not always announce itself. Sometimes it happens quietly, over spans so long they feel like permanence. And as we continue our journey, this sense of continuity follows us, a reminder that the trenches are not anomalies. They are expressions of a planet in motion. Could trenches hide unknown species? Even now, after centuries of exploration, the trenches remain mostly unexplored, not because we lack interest, but because access is limited, and time moves slowly here. Every descent into the deep reveals something new. Sometimes it is a species never seen before. Sometimes it is a familiar organism, found living far deeper than expected. These discoveries rarely arrive with excitement. They are quiet moments, a shape moving across the sediment, a faint outline captured on camera, a sample brought back and examined carefully. In the trenches, novelty is subtle. Life here does not evolve quickly. It adapts gradually, responding to stable conditions rather than sudden change. This means that species can persist, unchanged, for long periods of time, but it also means that entirely new forms may exist, simply waiting to be observed. Many trench organisms are small, difficult to detect, and easy to overlook. Some live buried within sediment, emerging only occasionally. Others drift slowly above the seafloor, appearing briefly, before fading back into darkness. Because exploration is rare, our picture of trench life remains incomplete. Each expedition offers only a glimpse, a momentary window, into a much larger system. This raises an intriguing possibility. How much life exists that we have never seen? How many species move quietly through darkness, never intersecting with human observation? The trenches offer ideal conditions for isolation. Populations are separated by distance, depth, and terrain. Communication between trench systems is limited. This allows life to evolve independently, shaped by local conditions, over long spans of time. In such environments, diversity can arise quietly, not through dramatic competition, but through slow specialization, a slightly different metabolism, a subtle change in structure, a new way of sensing the environment. These differences may never be noticed unless we look closely, and even when we do, they may take years to understand. The trenches do not reveal themselves quickly. They reward patience and careful observation. This is one reason why exploration of the deep ocean continues. Despite its challenges, not for conquest, but for understanding, each new species discovered adds to a larger picture, a picture of life that thrives without light, without warmth, and without abundance. Life that values balance over growth. And as we consider what may still remain hidden, it becomes clear that the trenches are not empty. They are simply quiet, holding their secrets without urgency, waiting to be noticed. When the time is right, trenches and earthquakes. Deep beneath the trenches, the earth is always moving, not suddenly, not violently, at least not most of the time, but steadily, patiently, as it has for billions of years. The trenches mark places where tectonic plates meet, and where one plate slowly sinks beneath another. This movement is known as subduction. It happens quietly, often unnoticed by those living far above. Centimeter by centimeter, year after year, the oceanic plate bends and slides downward into the mantle. As this happens, stress builds. Rock resists movement, holding tension, sometimes for centuries. Eventually, that tension is released. When it is, the result is an earthquake. But here, in the deep ocean, even earthquakes feel different. There is no shaking ground, no collapsing structures. Instead, there is motion, transmitted through water and rock as low-frequency waves. Most trench-related earthquakes happen far below the seafloor, deep within the Earth's crust. Some are so deep that their energy dissipates before reaching the surface. Others send subtle signals, traveling across entire ocean basins. These events are not sudden ruptures, but part of a long process, a slow adjustment. As the planet redistributes stress, the trenches themselves are shaped by this movement. Each small shift adds to their form. Each release of tension reshapes the surrounding rock, almost imperceptibly. Over time, these small changes accumulate. The trench deepens, or shifts, or changes angle. Nothing dramatic, just gradual evolution. Occasionally, a larger release occurs, an earthquake strong enough to move large sections of crust. When this happens near the ocean floor, it can displace water, creating waves that travel outward. But even these events are rare, and in the trenches themselves, the immediate effect is minimal. Life continues. Sediment settles again. The environment returns to stillness. Trench-dwelling organisms are adapted to this reality. They do not respond to every vibration. They sense movement, but do not panic. Their lives are shaped by stability, punctuated by rare change. From a distance, earthquakes feel dramatic, but in the trenches, they are simply part of the rhythm, a reminder that the planet is alive, adjusting, balancing, over immense spans of time. As we drift along the trench floor, the evidence of these movements is subtle. A slight shift in sediment layers, a gentle slope where none existed before, a quiet rearrangement of the seafloor. Nothing here feels chaotic. Everything feels inevitable. And as the earth continues its slow motion, the trenches remain patient witnesses, marking the boundaries of change. Without reacting to it, parallels between space and the deep. As we remain suspended in the darkness of the trenches, it becomes difficult not to notice a familiar feeling. The sensation is not unlike drifting through space. Here, there is no horizon, no clear up or down, just vastness and quiet. In many ways, the deep ocean and outer space share the same challenges. Both are hostile to unprotected human life. Both are defined by pressure, one by water, the other by vacuum, and both demand careful engineering, patience, and restraint. Explorers who descend into trenches often describe a sense of isolation, similar to that reported by astronauts. Communication is limited. Movement is slow. The environment is unforgiving. And yet, both places inspire calm rather than fear, because they strip away distraction. In space, there is no atmosphere to scatter light. In the deep ocean, there is no light at all. Both environments remove reference points. They force the mind inward. This is why research into trench life has implications far beyond Earth. If life can exist here, under crushing pressure, without sunlight, and with minimal energy, then life may exist elsewhere, beneath the icy crusts of distant moons, in subsurface oceans, in places that resemble trenches more than they resemble Earth's surface. The chemistry that supports trench ecosystems is not unique. It relies on reactions that can occur anywhere, given the right conditions. Water, energy gradients, time. The deep ocean provides a natural laboratory for understanding these possibilities. And in turn, space exploration informs how we study the trenches. Robotic probes, remote sensing, careful sampling, techniques developed for one frontier are often applied to the other. But beyond science, the connection runs deeper. Both space and the deep ocean remind us of scale, of how small we are within vast systems. They offer perspective, not through spectacle, but through silence. As we drift here, the trenches feel less like a place and more like a state of being, detached from surface concerns, removed from urgency, existing on a slower, more deliberate timeline. This is why, despite their danger, both space and the deep ocean continue to draw us in, not because they promise answers, but because they offer quiet. Why we rarely return, despite everything we've learned. Despite advances in technology, the trenches remain rarely visited, not because they resist us, but because they ask so much and offer so little in immediate return. Reaching the deepest parts of the ocean requires time. Preparation is slow. Descent is slower. Every system must be tested and tested again. There is no room for improvisation. Even small mistakes can become final. The cost of a single descent is high. Specialized vessels, trained crews, support ships. For most research programs, resources are limited. Choices must be made, and often, the trenches are postponed, not out of disinterest, but out of necessity. There is also a psychological weight to the deep ocean. Being enclosed, surrounded by darkness, and cut off from the surface is not easy. Even experienced explorers describe a sense of compression, not just from pressure, but from isolation. Time feels stretched. Silence becomes heavy. The trenches do not reward impatience. They require comfort with stillness. For machines, this is manageable. For humans, it can be challenging. This is why many modern explorations are conducted remotely. Robotic vehicles descend, capture images, collect samples, and return. They do not feel fear. They do not tire. But even machines are limited. They move slowly. They are cautious. The trenches demand it. And yet, the fact that we rarely return adds to their power. These are places that remain largely unchanged. Between visits, places where time continues uninterrupted, they do not accumulate footprints or signs of frequent passage. Each visit feels like a brief interruption in a much longer story. As we drift here, it becomes clear that absence is part of the trench's nature. They exist beyond regular observation, beyond constant interaction, and perhaps that is exactly how they endure. What the trenches teach us. As our journey through the trenches begins to slow, it becomes clear that these places offer more than data. They offer perspective. The trenches do not teach through spectacle. They teach through absence. Absence of light. Absence of noise. Absence of urgency. In a world shaped by speed, the trenches remind us that not everything needs to move quickly. That endurance often matters more than progress. Life here survives, not by competing, but by fitting in, by conserving energy, by waiting, by accepting limits. These are lessons easily overlooked at the surface, where abundance creates motion, and motion creates distraction. The trenches show us a different balance, one where stability is valuable, where patience is rewarded, where silence has meaning. They also remind us of scale, of how small our concerns are, within the context of a planet that has been changing for billions of years. Human history is brief. Even our deepest achievements barely register in the layers of sediment below. And yet, that realization is not unsettling. It is calming. It frees us from the pressure to rush, to conquer, to dominate. The trenches exist without asking anything of us. They do not require understanding or recognition. They continue, whether we observe them or not. In this way, they offer a quiet form of comfort, a reminder that the world is larger, slower, and more resilient than our daily worries suggest. As we linger here a little longer, suspended above the seafloor, it becomes easier to let go, to release tension, to allow thoughts to slow and drift. Much like the particles settling below, the trenches do not provide answers. They provide space to think, or not think at all. And as we prepare to move toward the end of our descent, that space remains. Waiting, unchanged, patient, gentle loop outro. As we reach the end of our descent, there is no need to surface just yet. The ocean does not ask us to hurry. Here, time continues without expectation. The trenches remain below, quiet, unchanged, holding their depth without effort. If your thoughts begin to drift, that is perfectly natural. This journey was never meant to end sharply. It was meant to slow and soften and gently repeat. You may notice the water around you again, heavy, still, supportive. Pressure exists, but it is balanced. Darkness surrounds, but it is calm. Life continues quietly below, waiting, as it always has. And far above, The surface moves on, unaware, unaffected. If your mind returns to the beginning, to the calm surface, to the first gentle descent, that is exactly where this journey can begin again. There is no finish line, only depth, only stillness, only the slow rhythm of a planet breathing beneath the ocean. And as the trenches remain unchanging, patient, so can you.